right, so this lesson right here is lessons 2122. Let's take a look at some parallel lines. What are parallel lines? These are two lines that will never intersect. A transversal. This is a line that intersects two or more lines. And the lines don't have to be parallel. So if I have a line that intersects two or more different lines, then that is called a transversal. Parallel lines theorems. These theorems show that the relationship between the angles formed when parallel lines are intersected by a transversal line. So here's what we have. Line L and M are parallel, which is the symbol for parallel. The notation on the line itself is these little feather marks. So I use two of them here, but they could be one or three. Any lines that have the same markings, like that, little arrows, like so, are parallel lines. And then I've numbered all the angles in there that are created. T stands for the transversal. 2-1 shows the conditional statements. 2-2 shows the converse of those statements. So we merged them together. And since they're both of them are true, each term that I wrote is written in a biconditional statement. First one. Consecutive interior angles. Sometimes it's called same side interior angles. Here's the parallel lines. That are these angles right here. Okay, I know it's hard to see, but they are supplementary. So I have parallel lines, then these angles that are in the interior on both sides, not just these, but on this side also, are supplementary. So up here in our picture, that means 3 and 5 are supplementary, and 4 and 6 are supplementary. By consecutive interior angles. Okay. Here's another one. Corresponding angles. These are angles that are on different parallel lines, but in the same position. So based upon our picture up here, we know that 1 and 5 are congruent. 3 and 7 are congruent. 2 and 6 are congruent. And 4 and 8 are congruent. They're in the same position, but on different parallel lines. Alternate interior angles. Alternate means on different sides of the transversal. Interior means between the two parallel lines. Like so. So in our picture up here, that means 4 and 5 will be congruent, and 3 and 6 will be congruent. Alternate interior angles. Last one. Alternate exterior. Outside the parallel lines, but on different sides of the transversal, are congruent. 1 and 8. 2 and 7. So we want to get familiar with these angle relationships. These angle relationships are very important. They go and continue on through many classes beyond this one. So you definitely want to make sure that you know them. Here's another theorem that might help us determine parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Makes sense? Okay. That's just a theorem that you might want to add to your little toolbox. And now I have some examples I want to go over with you guys. All right, so I'm going to show you these examples right now. So based off of those theorems I just gave you, and the fact that the measure of angle 4 is 118 degrees, find the measure of all the other angles and tell me why. There's a lot of ways to do this. Okay. First off, You have what? Linear pairs you can use. Linear pairs. We can use vertical angles and all the ones I just showed you. If angle 4 is 118, then I can say 4 is congruent to 2. So I can tell you that the measure of angle 2 is 118 because it is vertical angle. Now, what else can I say? I can say 4 is congruent to 8. Those are corresponding. I can say that 2 and 6 are congruent because they're corresponding. So let's add those together. So the measure of angle 8 equals the measure of angle 6, which is 118, because they are corresponding. So angle 2 is congruent to angle 6, and angle 4 is congruent to angle 8, corresponding angles. What else do I know? These are a linear pair, so I know they're supplementary. These are a linear pair, so I know they're supplementary. So I know that the measure of angle 1 is also the measure of angle 3, which is 62 degrees, because the measure of angle 4 plus the measure of angle 1 is 180, and the measure of angle 4 plus the measure of angle 3 is 180. They're supplementary. And I know that 3 and 7 are corresponding, 1 and 5 are corresponding. So I can say that the measure of angle 5 is the measure of angle 7, which is 62 degrees. Because angle 1 is congruent to angle 5, and angle 3 is congruent to angle 7, because they are corresponding. So we've measured all of them. Again, there's more than one way to do all this. This is just one way of doing it. You could have used different theorems and different relationships to explain things other than the ones I gave. Okay? But this is just one way to do it. What information do I need to know to show that these two lines are going to be parallel? What must be true for that to occur? Excuse me. So we look at this and we try and find the relationships. Okay? So you look for things that relate C and D together. For example, if I look closely here, I can see that 3 and 5 are alternate interior angles. See how this one's on C and this one's on D? So with that in mind, I can say angle 3 must be congruent to angle 5 by alternate interior angles. Okay? If I have that, then these two lines will be parallel. Is there any more? Well, nothing's going to relate to this to 2. Okay? I can't do consecutive interior because these are for interior between A and B. Remember, I want to find C and D. There is one more, and that is 3 and 6. They are in corresponding position on C and D. So if angle 3 is congruent to angle 6 by corresponding, then C and D would be parallel. So that's what you want to look for. An algebratized to things would be like this. What value of x do I need to show that u and v are parallel? So what is the relationship between these two angles that are given? Well, they're alternate interior angles, which means they have to be congruent for these two lines to be parallel, which means 16x plus 8 must equal 120. So let's solve this. Take 8 away from this, and we get 112. Divide by 16. And so what is 112 divided by 16? And we get 7. So when x is 7, these two angles will be congruent, which means these two lines have to be parallel. And so that's how that works. So that's what 2.1 and 2.2 are about, and we'll take questions and more problems together in class.